Hello friends, myself Rajendra Mahajan presenting my video on eigenvalues and eigenvector. Let us solve the problem. Find eigenvalues and eigenvector corresponding to the largest eigenvalue for the matrix A containing elements 1, 1, 3, 1, 5, 1, 3, 1 and 1. And therefore, to obtain the eigenvalues and eigenvector, first of all, we have to obtain the characteristic equation. Therefore, that characteristic equation is given by determinant of A minus lambda I is equals to 0. That is, subtracting lambda from this principal diagonal element, we get the determinant as 1 minus lambda 1, 3, 1, 5 minus lambda 1, 3, 1 and 1 minus lambda, and we have to equate that determinant to 0. This is one way to obtain the characteristic equation, or we can use the shortcut method. Characteristic equation for the third order determinant is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equals to 0. We call this equation 1, where S1 is the sum of the principal diagonal element. Principal diagonal means diagonal from left to right, and therefore it is 1 plus 5 plus 1. We get that value as 7. S2 is the sum of the minors of the principal diagonal element. I is equals to 1 to 3. And therefore, we try to find out that minors. Therefore, the minor of the first diagonal element, neglecting first one, first column, determinant of this 5, 1, 1, 1. Next, determinant of the second diagonal element, neglecting second row and second column, determinant of 1, 3, 3, 1. And minor of the third diagonal element, neglecting third row and third column, determinant of 1, 1, 1, 5. And therefore, we get the value 5 minus 1 as 4, 1 minus 9, we get minus 8, and 5 minus 1, we get 4, and therefore it is 8 minus 8, we get that value as 0. Then determinant of matrix A is determinant of 1, 1, 3, 1, 5, 1, 3, 1, 1. Evaluating as usual, we are evaluating third order determinant. It is 1 into this determinant of 5, 1, 1, 1 means 5 minus 1 minus 1 into neglecting first row and second column, we get determinant of 1, 1, 3, 1 means 1 into 1, 1 minus 3 plus 3 into neglecting first row third column, determinant of 1, 5, 3, 1, it is 1 minus 5, 3 is 15, and therefore 1 into 4 we get 4, minus 2 into minus 1 we get plus 2, and minus 14 into 3 minus 42. Okay, and therefore sum of this 4 plus 2 minus 42, that value is minus 36. Substituting these values in equation 1, we get characteristic equation is lambda cube minus s1 lambda square. S1 is 7, S2 is 0, 0 lambda, and minus determinant of A, minus and that minus, it becomes plus 36 is equals to 0. That is, we have lambda cube minus 7 lambda square plus 36 is equals to 0, equation number 2. Here the first step is completed. In next step, we require to find out the roots of this equation. Therefore, as it is cubic equation, applying synthetic division technique, coefficients are 1, minus 7, 0 and 36. Then by trial and error, we check whether plus 1 is the root. Sum of the coefficient is not 0, therefore 1 is not the root. Then alternate sum of even and sum of odd coefficient. It is 1 plus 0, 1 and minus 7 plus 36. That is 29. Are not equal. Therefore, minus 1 and 1 are not the roots. We go for plus 2, minus 2 like this by trial and error technique. Therefore, I will go directly for minus 2 suppose. 1 as it is, no change. 1 into minus 2 we get. Therefore, sum is minus 9. Minus 9 into minus 2 we get plus 18. Sum is 18. 18 to the 36 with minus sign. Minus 36. Sum is 0. And as last sum is 0, first value is lambda is equals to minus 2. Remaining factor is lambda square minus 9 lambda plus 18 is equals to 0. Factors of 18, so that the product is 18 and sum is minus 9. Therefore, it is lambda minus 6 and lambda minus 3. We get lambda is equals to 6 and lambda equals to 3. The product of this 6 into minus 3 is plus 18, and minus 6 plus minus 3 is minus 9. And therefore, we get lambda is equals to minus 2, 3 and 6. These are the eigenvalues. Then we cross check it. Sum of the eigenvalues, 9 minus 2 we get 7, and the sum of the principal diagonal element, that is the value of S1, is 7. The first property is satisfied. We get 7 is equals to 7. Then second property, determinant of A is minus 36. That must be equals to the product of this eigenvalues. Therefore, 6 to the 12 and 12 into 3, it is 36, and this minus sign, therefore minus 36. The product is equals to the value of determinant. Second property is also satisfied, and as both are satisfied, values obtained are correct one. It is obtained by a matrix of A minus lambda I into matrix X is equals to 0, equating it to 0, and then applying Cramer's rule, we can obtain the eigenvector corresponding to lambda is equals to 6. Therefore, convert this determinant in matrix form. Therefore, we get that matrix as one minus lambda, 1, 3, then 1, 5 minus lambda, and 1, 3, 1 and 1 minus lambda. This is the matrix of A minus lambda I into a column matrix x1, x2, x3 or xyz, whatever you want. I will take x1, x2, x3 and equals to a 0 matrix. And then put lambda is equals to 6 here. We get 1 minus 6. 1 minus 6 is minus 5. 1, 3, 1. 5 minus 6 we get minus 1. 1, 3, 1. 1 minus 6 again minus 5. Multiplied by a column vector x1, x2, x3 and equals to 0. That is, we get converting this in equation form, multiplying by row to that column. Here matrix multiplication is possible and therefore we get minus 5x1 plus x2 plus 3x3 is equals to 0. Second equation, x1 minus x2 plus x3 is equals to 0, and then multiplying by third row to that column we get 3x1 plus x2 minus 5x3 equals to 0. Then considering any two equations, I am considering first and second, therefore we consider this first two and then solving by Cramer's rule. It is x1 divided by minus x2 divided by x3 divided by and equals to some non-zero scalar quantity k. Neglecting the first column and take a determinant of coefficient of the remaining. Therefore, coefficients are 1, 3, minus 1, 1. Then neglect x2 column of x2 and determinant of the remaining, that is minus 5, 3, 1, 1. Then neglecting column of x3 and determinant of remaining minus 5, 1, 1, minus 1. And then solving it, it is 1 minus minus plus 3 minus x2 upon minus 5 and minus 3 x3 upon plus 5 and minus 1 equals to k. X1 by 4 minus x2 upon minus 8, minus minus it becomes plus, therefore x2 upon 8, x3 upon 4 equals to k. It implies we get x1 is equals to 4k, equating first with last, then equating second with last, we get x2 is equals to 8k and x3 is equals to 4k. Therefore, that eigenvector corresponding to lambda equal to 6 is 4k, 8k and 4k. Or dividing throughout by 4, we get that vector as k, 2k and k. As eigenvector for largest eigenvalue lambda equal to 6. This is the end of the third part. Therefore, once again, we have to complete this problem in three parts. First part, find the characteristic equation. In second part, find the eigenvalues. And in third part, find the eigenvector as per the requirement. Here, we have to obtain for the largest eigenvalue. Largest eigenvalue is 6. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.